Where do black holes actually lead? Chapter 1. The Door with No Handle. There is a certain kind of question that refuses to sit quietly. It knocks from the edges of our understanding, taps the chalkboard while the professor talks, hovers at the rim of a telescope eyepiece the way a moth hovers at a porch light. Where do black holes actually lead? Imagine you're standing at the threshold of a door with no handle, no hinges, no visible frame, just a flat, perfect circle in space, darker than midnight, darker than the idea of midnight, the place where brightness goes to confess its limits. This is the event horizon. On one side, the universe we know, with its messy galaxies and honest starlight and everything that can, in principle, still send you a message. On the other side, a territory drawn by equations and guarded by caution. Your question points beyond that border. It asks not only what happens in there, but where in there might be. Let's walk toward the door together slowly, carefully, and I'll tell you what we know, what we suspect, and what we are brave enough to imagine. Number, a shape made of time. To understand where black holes might lead, you must first accept a simple truth that never feels simple when you first hear it. Gravity is not a force pulling you downward. It is the shape of time nudging you along its curves. Einstein traded Newton's invisible hands for a fabric spacetime that bends when pressed by energy. Mass tells spacetime how to curve. Curved spacetime tells mass how to move. A black hole is what happens when that curvature becomes so extreme that all possible paths forward, literally forward in time, tilt inward. Picture a river whose current grows stronger and swifter as you approach a waterfall. At a safe distance, a fish can swim against the current. Closer in, the fish must struggle. Cross a certain point, and even a salmon at its peak, a living arrow of muscle and intent, cannot fight the flow. That point in the river is the point of no return, and the river, my brave friend, is time. From far away, a black hole looks like a region where light itself can't swim fast enough upstream. That's the event horizon, not a material surface, but a boundary in the geometry of the universe. It is the place where the current of time flows inward at the speed of light. Inside, all paths point deeper. There is no going back. So, where does that current carry you? Number. The descent, what falling in feels like. Close your eyes and imagine crossing the horizon. No alarm rings. No sudden jolt. If the black hole is supermassive, millions or billions of suns crumpled into a single point, the gradient in gravity across your body is gentle at the horizon. Tidal forces are small out there. You float through, and you might not even notice the exact moment. For you, time feels normal. Your heart works, your watch ticks, your thoughts arise and dissolve, anchored by the metronome of your metabolism. But the universe you left behind is already losing sight of you. To someone watching from far away, your approach slows, reddens, fades. You never quite appear to cross. It's as if the door has swallowed you in silence, then rearranged the dust to hide its crime. Inside, the light is not gone. It is just trapped, like birds that flew into a house and cannot find the open window. The very language of direction changes meaning. Toward the center is not a choice, it's what after this moment means. You fall because time itself falls. Eventually, the river reaches its end. The singularity, our equations draw it as a point where curvature becomes infinite, where density soars beyond any finite number, where the grammar of space and time fails. It is a cliff in our math, a confession that our map ends here. The singularity is why your question is not just curiosity. It is a demand for a better theory. If a black hole is a door with no handle, the singularity is the lock on the other side. Where does the door lead? Into the lock. What's beyond the lock? We don't know yet. Number, the honest answer. Physicists are good at many things. Measuring starlight that left its source before our species had a name, building machines that split protons into their secrets, extracting order from the jitter of particles that exist for less time than it takes to think the letter T. But we are also, at our best, honest. And the honest answer to your question is this. According to the theory we trust most on these scales, general relativity, black holes do not lead anywhere you could survive or send a postcard from. They lead to a singularity in your future, an end of your path, a full stop at the end of your story. And yet, because the universe is generous, and because human beings are stubborn, this cannot be the last word. The equations that give us singularities are also the equations that break at singularities. We need quantum gravity, a theory that marries Einstein's smooth curves to the grainy music of quantum mechanics. We don't have that full symphony score. We have sketches, movements, themes that keep returning. And those themes hum with possibilities. Number, the temptation of other places. You've heard the whispers, white holes, wormholes, baby universes budding off like cosmic coral. The ideas are not all fairy tales. In the mathematics of general relativity, time reversing a black hole solution produces a white hole, an object that nothing can enter and everything must flee. Stitch a black hole to a white hole and you get a wormhole, a tunnel connecting two distant regions of space-time, an Einstein-Rosen bridge. It's a bridge that, in its simplest form, collapses too quickly to cross. It pinches shut faster than any traveler can traverse it. The geometry forbids the fairy tale. But researchers have tried to brace it open with exotic matter stuff whose pressure and energy subtract rather than add, the kind of thing quantum fields can sometimes produce in fleeting whispers. Stable wormholes remain hypothetical. They are like mirages kept alive by equations that glow hot with speculation. If they exist, they would change what lead to means. A black hole could open not a lock, but a hallway. You might enter near Sagittarius A times, the supermassive black hole at our galaxy's heart, and emerge near some distant quasar, or, in another universe entirely, the way a thread emerges from a different hole in the same fabric. But to believe that is to believe in a stack of maybes. Maybe quantum gravity permits exotic matter in stable quantities. Maybe the violent collapse of a star arranges the tunnel just so. Maybe the turbulence of falling worlds doesn't shred the passage as it forms. Science is faithful to evidence, and the evidence, so far, points to doors that close, not corridors that carry. Still, I want you to know the shape of the dream, because sometimes dreams sketch the scaffolding we'll later build in steel. Number, the paradox and the ledger. There is a different route to your question, one paved not with tunnels but with bookkeeping. Black holes are thermodynamic creatures. They glow faintly by quantum rules, with a temperature proportional to their surface gravity. This is Hawking radiation, particles born from the restless foam of quantum fields near the horizon, one partner falling in, one partner escaping, as if the black hole were slowly exhaling the energy it once swallowed. Over unimaginable timescales, a black hole can evaporate, Information, however, is fussy. Quantum mechanics treats it like a ledger that must always balance. If a black hole simply ate a library and later evaporated into dull thermal fog, then the fine details, the words, the sentences, the subtle correlations in the books would vanish from the universe's memory. That would be a crime against quantum law. This is the information paradox. What does this have to do with where black holes lead? Everything. If information is preserved, then in some sense the inside must be re-encoded on the outside. The door leads not to a secret room, but to a reorganization of the room you started in. The holographic principle suggests that everything happening inside the volume is somehow reflected on the boundary. The horizon is not just a place where light fails to escape, it's a canvas where the microstates of the black hole, the ways it can be internally arranged, are inscribed. If that principle is right, then the black hole leads to the universe itself. Rewritten, there are other proposals: firewalls, searing walls of high-energy quanta at the horizon that torch the gentle passage I described, arise in some arguments meant to protect the sanctity of information. Complementarity says that different observers can keep different, mutually incompatible stories, and physics will never force them to compare notes in a way that yields a contradiction. In one story, you fall in smoothly. In another, you are smeared across the horizon and re-emitted over cosmic ages. Both can be true, so long as no one can stitch them into a paradox. This may sound like philosopher's fog. It's not. It is the sweat of people pushing logic to its limits, so the universe will tell them how to stop sweating. Experiments are not easy when your subject is darkness itself, but there are hints. The flicker of X-ray light as matter swirls toward doom, the millisecond ringing of space-time after two black holes collide, the ghostly silhouette of a shadow captured by an Earth-sized telescope. Each clue tugs at the edge of our ignorance, unpicking the hem number. If you wrote a photon, let's try an experiment of the imagination. You are not flesh now. You are a beam of light fired inward, a messenger made only of energy and direction. As you cross the horizon, nothing interrupts your flight. The curvature funnels you toward the center. If the black hole is small, born from a single star's death, tidal forces will tear you apart if you were matter. As light, you are unterrible, but your path still terminates at the singularity. You reach the end, not because something stops you, but because there is no later beyond that point. It isn't a place, it is a time that all times ahead of you run into. What does the singularity lead to for you? The question dissolves. The road ends. Now rewind and give the black hole mass like a mountain of galaxies. The interior expands with possibility. Some solutions to the equations, idealized, symmetric, develop inner horizons, places where the flow of time and the identity of space-like and time-like directions perform a dance too complicated for words to follow. In those ideal worlds, the interior might connect to another region, a mathematical elsewhere. But real black holes are born messy, with turbulence, with magnetic fields snarling like wire, with quantum froth. The tidy bridges rot. Our best sense is that even for supermassive black holes, all roads lead inward, and inward leads to an end. But that sense rests on pillars built from classical gravity alone. At the Planck scale, where lengths are so short and energies so high that space-time's smoothness must fail. Quantum gravity could replace the singularity with something else. A bounce, a knot, a seed. Number, the bounce and the bud. Loop quantum gravity, one contender in the arena, suggests that space-time has atoms quanta of area and volume. In that case, collapse might halt when the density reaches a maximum set by the quantum of volume. Instead of a singularity, the core rebounds. What follows? Perhaps an explosion inside that is sealed from the outside, a baby universe budding behind the horizon, an umbilical that never opens, a branching of reality's tree. From our perspective, nothing escapes. From the inside's perspective, you are born into a new cosmos, never to return. If so, where does a black hole lead? To elsewhere, irrevocably. This is not settled science. It is not even a majority opinion. It is a reasonable idea carried by mathematics that has not yet earned its keep by predicting something we can measure in the sky. But it shows you the kind of answers we are entertaining, not because we want them to be true, but because your question requires more than we fall and that is all. Number, the human ledger. Pause with me in the quiet between speculations. Let's stand again at the horizon, not as physicists but as people. Everything that falls toward a black hole adds to it. It increases the area of the horizon. It deepens the night. In that sense, a black hole is a ledger of a region's history, an archive that stores by swallowing stars, gas, planets, perhaps terribly habitats and hopes. Is there a way to rescue what goes in? Not physically, not in time to matter to those who loved it, but there is a way to listen to the stories the ledger tells. The roar of matter heating up in the accretion disk before its final plunge writes in light. The shape of the black hole's shadow sketches the geometry of the surrounding space. The ring down, the way space-time vibrates after a merger, tells us the mass and spin, like the timbre of a bell, tells you its size. One day, maybe, a subtler listening will emerge. Correlators decoded from Hawking radiation, patterns teased out of randomness like constellations from stars. Not fanciful but factual, we are learning to read the universe in finer fonts. The black hole's future might be written in a kind of code we don't know how to break yet. When we do, the answer to where does it lead might be to comprehension, not an elsewhere in space, but a nearer place in understanding. Number, a map for the second chapter. To make a promise to you, dear listener, I'll chart the path ahead. In the next chapter, we will descend deeper into the physics that frames these possibilities. We'll trace the mathematics of horizons and the thermodynamics of area. We'll meet the thought experiments that sharpen paradox into progress. Falling observers and stationary ones, entanglement stretched across the sky, teleportation at the edge of a shadow. We'll examine the evidence, the Event Horizon Telescope's images, the gravitational waves' syllables after collisions, and ask what they do and do not authorize us to say. We will face the singularity again, this time with the company of quantum mechanics. We will consider whether white holes can exist as the time mirror of black holes, whether wormholes can be engineered not with speculative matter, but with clever quantum tricks, whether ER equals EPR. The proposal that entanglement and wormholes are two sides of the same coin offers a path from metaphor to mechanism, and we will keep returning to your question, refusing to let it soften into a vague nowhere. By the end, I will give you the strongest answer that the best minds can defend, and I will give it to you in the spirit of science, not to end your wonder, but to focus it. For now, we end where we began, at the door with no handle. We have learned that it is not a door in the ordinary sense, not a gate you can open with a key of cleverness or endurance. It is a boundary in the flow of time, a surface where the universe's story turns inward and writes in a dialect we are still studying. Where do black holes actually lead? They lead us to the edge of our maps. They lead to a demand for deeper laws. They lead to humility, to instruments built on mountaintops and in underground caverns, to collaboration across continents, to chalk dust on fingers and code running in the night. They lead to the place where patience meets imagination. They lead, above all, to the promise that the unknown is not empty. It is full of futures, of equations not yet written, of answers waiting to be earned. Come with me. In the next chapter, we will step through not into the black hole itself, but into the space of ideas that lets us peer farther than light can travel. And if we are careful and lucky, we might learn to say where in there goes not with certainty, but with a clarity that honors both the universe's mystery and your hunger to understand it. Chapter 2. Through the mathematics toward the meaning. You and I have stood at the threshold and felt the tug of time's river. We've told the truth that general relativity offers inside the black hole all futures point inward. The road ends at a singularity where our equations confess their limits. But if this were the whole story, there would be little more to say, only an epitaph for falling worlds. Instead, this chapter is a climb down, a ladder of ideas, rungs of observation, rungs of theory toward a clearer answer to our question, where do black holes actually lead? Not only in the geography of space-time, but in the unfolding of science, in the architecture of knowledge, in the way we tell stories about reality without cheating. I will introduce some technical ideas. I will translate them into plain speech, and I will keep one eye, always, on the human meaning of the answer we are building. 1. The horizon as a thermostat. Begin with a paradox. Nothing escapes a black hole, and yet a black hole has a temperature. Temperature belongs to systems with microscopic constituents, atoms, molecules, the jostling crowd from which heat arises. When Stephen Hawking showed that black holes radiate, it wasn't a poetic claim, but a calculation in quantum field theory on curved space-time. Near the horizon, the vacuum is not empty. It seethes with temporary pairs particle and antiparticle borrowing energy from uncertainty for the briefest time. At the edge, geometry becomes a collaborator. One member of the pair can fall in while the other flees outward, and to a far observer, this looks like the black hole glowing with an exceedingly faint heat. That heat implies entropy, a measure of how many microstates could underlie the same macroscopic object. Jacob Bekenstein argued for this before Hawking supplied the radiation that forced the cosmos to agree. Entropy for a black hole is not proportional to its volume, but to its area, the area of the event horizon. That statement is so strange it should slow your heartbeat. The information capacity of what's inside scales not with the room available, but with the skin. This is the hint from which the holographic principle grows, the idea that a region's interior can be fully described by degrees of freedom living on its boundary, much as a hologram encodes a 3D scene on a 2D plate. Where does a black hole lead? Even now, a first answer emerges to a new bookkeeping of reality, where surfaces count more than volumes and the universe begins to look like a story told on its edges. 2. The page in the fire. Now imagine you feed the whole a book. The cover softens from blue to coal as it falls. The letters collapse into a scream of infrared. Dust and paper turn to plasma, then patternless heat. From the outside, patience becomes heroic. You must wait longer than the age of the universe for a stellar black hole to evaporate, longer still for a supermassive one. Suppose you are immortal and you wait. What trickles out to you is thermal radiation, featureless warmth. Where did the story go? Quantum mechanics stands up in court for information. It says evolution is unitary, reversible in principle, that the correlations encoded in a state at the start must be present at the end, even if they are encrypted beyond recognition. Don Page computed that if information is preserved, the entropy of the radiation should rise. At first, everything looks thermal, then reach a peak halfway through the black hole's life, the Page time, and then fall as the outgoing radiation becomes entangled with what has already escaped, carrying correlations that restore the ledger's balance. That curve up, then down, became a testable shape for an untestable epoch. Decades later, using tools from quantum gravity called quantum extremal surfaces, theorists reproduced the Page curve from first principles. It was a triumph of reasoning, not an observation but a map consistent with quantum law and the thermodynamic behavior Hawking had revealed. It tells us that, from the outside, a black hole leads to a long conversation whispered in heat, a story whose plot is concealed in correlations too delicate for mortal instruments today. Inside, for a falling traveler, the tale is different. The book burns only at the singularity's edge. Crossing the horizon feels ordinary. Complementarity, one of the great ideas of the late 20th century, declares that the two stories need not collide. No single observer sees both as true in a way that conflicts. The universe relieves us of the obligation to reconcile incompatible diaries, when the act of comparison would require superhuman feats escaping the interior to report what you saw, while your twin outside reconstructs your pages from light. Where does the whole lead? To two narratives that cannot be forced into one paragraph, and to a physics that is grown up enough to accept that fact. 3. Fire at the door? Then came a shock. If the outside radiation carries away information and the inside remains a smooth passage for a falling observer, quantum entanglement appears to be stretched too thin, like a blanket that cannot cover both sleepers. The AMPS argument, named for Almheri, Marolf, Polchinski, and Sully, suggested a cruel alternative, a high-energy firewall at the horizon, burning any infaller to ash. The door with no handle becomes a door with a flamethrower. If true, the firewall would demolish the equivalence principle, the idea that locally, gravity can always be transformed away, that free fall is indistinguishable from floating in deep space. Many physicists view this as too high a price. Others embrace the cost. The debate sharpened the problem. It reminded us that preserving information is not an aesthetic preference, but a structural necessity for quantum mechanics, and that GR's serenity must be earned anew in the quantum age. Several proposals tiptoe between the flames and the fall. Soft hair on black holes, subtle degrees of freedom on the horizon that can store information, state-dependent interior operators that reshuffle our notion of what inside means, and ER equals EPR, to which we now turn. Threads and bridges. ER equals EPR is a slogan with the charisma of a prophecy. ER stands for Einstein-Rosen, the bridge, the wormhole. EPR stands for Einstein-Podolsky-Rosen, the paper that challenged quantum entanglement's completeness. The conjecture, perhaps entanglement and wormholes are aspects of the same underlying thing. Two black holes maximally entangled with each other could be two mouths of a geometric tunnel. No faster than light messages would pass. The bridge would be non-traversable, but the language of geometry and the language of quantum information would learn each other's grammar. If this is true even in some qualified sense, then where becomes a relational notion? The interior of a black hole might be located not in ordinary space, but in patterns of entanglement with the outside universe. Space-time itself might be woven from entanglement threads knitting regions into neighborhoods. Where does a black hole lead? To the insight that asking for a physical hallway might be less fruitful than asking for a network of relationships. The answer is not a tunnel you can walk through, but a map of correlations you can, in principle, decode. 5. The observers we are and aren't. Physics is a science of observers who do not exist. Idealized, immortal, perfectly patient, carrying detectors that never fail, they ask the universe questions with infinite precision. In textbooks, these observers can hover at any altitude, measure anything, undo any measurement, compare notes after centuries, survive absurd journeys. We use them the way architects use plumb lines and perfect circles, to anchor an argument that otherwise would drift. But we are not those observers. We are finite, regional, brief. For creatures like us, the story of where black holes lead is filtered through what can be known by bounded beings. From far away, the hole leads to a faint glow and a shadow. From nearby, it leads to desperate light, a disk of matter heated to X-ray fury. From inside, it leads to an end none of us can report. Beyond the end, in some proposals, it leads to a birth so cut off from our region that lead becomes a metaphor, not a journey. Accepting this is not defeat. It is liberation from a childish picture of science as a list of answers. Science is a craft for building better questions, each nailed to evidence, each sanded smooth by logic. In that craft, black holes lead to tools that work elsewhere. Quantum error-correcting codes to model holography, new mathematics for entanglement, technologies sharpened by the need to see shadows on galactic scales and ripples in space-time born in ancient collisions, the bell and the shadow. Let's speak of the evidence, for it is our ballast. When two black holes merge, they ring. Space-time quivers like a struck bell and then relaxes into a simple, final note determined by the mass and spin of the remnant. That ring-down, those gravitational waves match the spectrum predicted by general relativity with astonishing fidelity. The simplicity is a lesson. Black holes have no hair. The saying goes, no extra details beyond mass, spin, and charge. The world does not keep a diary on their surface. It keeps a ledger. How heavy, how fast, what electric character. Every other feature of what fell in is forgotten, macroscopically. When a giant telescope stitched from radio dishes across the Earth stared at M 87 times in Sagittarius A*, it saw a ring and a shadow, the silhouette of nothingness, a negative space at the center of a bright, whirling storm. The size of the shadow matches the predictions of GR, the shape and variability of the luminous plasma around it match models refined by the equations of magnetized fluids flowing at nearly the speed of light. There is beauty in the agreement. These observations do not tell us about the singularity. They do not adjudicate the firewall debate, nor do they sign the birth certificate of baby universes, but they harden one truth. Outside the horizon, down to the very lip of forever, GR holds with stoic accuracy. Any new physics must reduce to it in that regime. Revolution must be whisper, not shout. Where do black holes lead in the only sense experiments can insist upon today? To the confirmation that space-time is elastic, that gravity is geometry, that the cosmos is not offended by our models, but echoed by them. The speculative garden, walk, don't run. We promised not to stray too far into fairy tale, and we will keep that promise. But it would be dishonest not to name the garden where speculations grow. In carefully engineered scenarios, eternal black holes in asymptotically anti-de Sitter space wormholes appear in the mathematics as stable, non-traversable structures. In laboratory quantum systems that mimic aspects of holography, information that falls into a toy black hole can be recovered with techniques akin to decoding and error-correcting code. In some approaches to quantum gravity, the singularity is replaced by a bounce, and the interior inflates into a new region that never speaks to ours. These are not established facts. They are the scaffolds we erect while building a cathedral whose foundation is still being poured. The garden is worth visiting with humility. It keeps the imagination supple. It reminds us that where can be a notion molded by the theory that contains it. It asks us to be precise about words like lead for whom, along which curve, with what capacity to signal back. If, one day, we prove that black holes spawn disconnected universes, then, to beings within those buds, the whole will have led to a cosmos. To us, it will have led to silence. Both statements can be true together. And the ethics of edges. You might ask, why all this effort for places no one returns from? Why pour human talent into shadows? The answer loops back to us. Black holes sit at the limits of our theories. Push against an edge, and the entire interior of a field adjusts. Laser interferometers, capable of measuring ripples smaller than a proton's width, require technologies that cascade outward into medicine and materials and measurement. World-spanning collaborations like those that image a shadow require software, standards, cultures of sharing that spill over into other sciences. Students trained in these crucibles carry their skills into domains far from gravity: climate modeling, data science, secure communications. There is another ethic, the ethic of awe. To care about what you cannot use is a rehearsal for caring about people you will never meet, for landscapes you will never walk, for futures beyond your years. The discipline of telling the truth about black holes, no wishful wormholes without equations to hold them up, translates into a civic discipline: no comfortable lies. The humility of saying, "we don't know," becomes a civic virtue too. If we learn to live with uncertainty here, perhaps we can live with it in our politics and our private griefs. Where do black holes lead? To better instruments, better institutions, better habits of mind. The universe trains us in its gymnasium. 9. The most honest mapper. Let us now answer in the plainest terms our shared question, distilled from everything we've said. Asterisk, asterisk, asterisk. According to classical general relativity, asterisk, asterisk, the interior of a black hole leads to a singularity in your future, a boundary of time where your path ends. There is no elsewhere beyond that singularity within the theory's domain. The whole is not a tunnel but a terminus. Asterisk, asterisk, asterisk. According to quantum field theory on curved space-time, asterisk, asterisk, black holes radiate and can, in principle, evaporate. If unitarity holds, the information about what fell in must be preserved in subtle correlations among the outgoing quanta. In that sense, a black hole leads, over vast times, to a re-expression of its contents in the universe it inhabits. Scrambled, delayed, but not destroyed. Asterisk, asterisk, asterisk. According to the holographic principle, asterisk, asterisk, the interior may be equivalently described by degrees of freedom living on or near the boundary. Where becomes a question about representation. The whole leads to a dictionary between volumes and surfaces, between geometry and entanglement. Asterisk, asterisk, asterisk. In speculative quantum gravity scenarios, asterisk, asterisk, black holes might lead to white holes, to bounces, to baby universes, to wormholes that are non-traversable, and perhaps, in exotic constructions, barely traversable under special conditions. These are not established features of our cosmos. They are possibilities under active investigation. Asterisk, asterisk, asterisk. For observers like us constrained by time and technology, asterisk, asterisk, black holes lead to data. Gravitational wave songs and radio silhouettes, X-ray flares and near-infrared flickers. They lead to tests that, so far, have crowned GR with laurel and tasked quantum gravity with consistency. This is the most honest map we can draw today. It is not a dead end, it is a set of arrows, each labeled with a condition and a promise. Parable of the two clocks. Permit a final parable to set the answer in your memory. Two clocks are made in the same workshop. One is sent to live on a mountain, tuned to the quiet rhythm of thin air. The other is sealed in a capsule and dropped toward a black hole. The mountain clock ticks, as it always has, counting noon for shepherds and telescope techs. The falling clock ticks normally, too, from its own point of view, keeping perfect time even as the horizon swallows it silently, like ink drawn into cloth. Years pass. The mountain clock watches the sky for the ring of space-time. When black holes meet, it reads the light around a shadow. It hears heat whisper from the future. It records patterns and feeds them to minds that wring from them theorems and software and doubt. The falling clock has no correspondent. Its letters are not posted. Its story is not told, but we refuse to call it meaningless. Instead, we change what we mean by told. We learn that the telling is written on horizons, that the archive is area, that time can split a single truth into diaries that never compare. We accept that some tales are true without being shareable, and some are shareable only as ciphers across ages that dwarf civilizations. Ask again, where do black holes actually lead? The falling clock would say, to an end. The mountain clock would say, to knowledge. The equations say, to a boundary where the classical breaks and the quantum must speak. The ethicist says, to humility and wonder. The engineer says, to instruments that can weigh the trembling of reality. The poet says, to a sharper edge on awe. All are correct because lead is a bridge word between here and there, between now and later, between what is and what we can know. Black holes do not merely take, they also point. Number 11, a door reimagined. Return with me to the door with no handle. It stands as it did a circle into which even light must bow. In chapter 1, we named it. In chapter 2, we traced the house around it. We found no hallway we can stride down, no postcard we can send from the far side. We found, instead, an economy of truth. The door does not open for bodies. It opens for questions. It opens for mathematics that reconcile heat with gravity, for principles that regard surfaces as scriptures, for conjectures that braid bridges with entanglement. It opens for collaborations measured in continents and decades. It opens for a civilization that chooses to spend brilliance on mysteries it cannot sell. So let this be the book's last image. Not a hero crossing into an elsewhere, but a community gathered at the threshold, technicians and theorists, students and elders, the patient and the curious listening. On the other side, time falls inward. On this side, ideas rise. Where do black holes actually lead? To the singular end of a traveler's path inside, to a long encrypted conversation outside, to the edges of our maps, to new instruments and new alliances, to a future theory in which singularities are not dead ends, but transformed beginnings. They lead, above all, to a more exacting love for the world, a love that asks for evidence, accepts uncertainty, and chooses wonder over wish. The door with no handle remains, yet we are different now. We carry with us a map not of corridors but of concepts, not of elsewhere but of understanding. If, one day, the universe grants us a clearer answer, if a measurement teases out correlations in Hawking's warmth, if a new image resolves the dance of light on the lip of forever, if a final theory removes the lock and shows us the mechanism, we will add a new chapter to the book humanity writes across the centuries. Until then, this is enough. Not the end of the question, but a pause in its music. Not a period, but a semicolon. We have not stepped through the door. We have learned what it means to stand before it and listen well.